Welcome to the May 27th Zoffee, and today we're going to be talking to Professor Tim Weis, who is an engineering professor at the University of Alberta and an expert on integrating, well, renewable energy and power grid, and especially with a focus on Alberta. So we're really excited to talk to him. Welcome to the Zoffee, Tim. So, Tim, before we started recording, you were telling us about the arrangement you have with the University of Alberta. Why don't you give us just a brief overview of what it is that you teach there?
Sure. So the very hopefully quick version of what I do at the university is I teach courses in thermodynamics and energy conversion within the Department of Mechanical Engineering. And I have a research students and program that are part of the School of Business where we actually look at renewable energy integration into the Alberta electricity market and sort of how those two things interact with each other.
Yeah, that's perfect, because that's exactly what we want to talk about today. So let's talk about in the most general terms, Tim. I mean, this has come up a number of times in Zoffees and conversations about how do you integrate renewables into a power grid, because we're used to thinking in terms of base load, you know, where you need a steady source of supply of electricity all the time. And of course, renewables are intermittent. So what's the, you know, how does that basically work?
Well, I mean, broadly speaking, the electricity system has, I think it's important to take a big step back and sort of remember the electricity system always has fundamental, huge amounts of redundancies built into it. We have incredibly reliable power. I don't think people appreciate how reliable the whole overall system is. And that's because there's always gives and takes in the system, and there's always one plant moving up, one plant moving down, one plant coming offline, another one reacting to demand coming up and down all the time. And so the system is incredibly dynamic, but it's also fundamentally built on having redundancies. And so, you know, we have that already built into the system, and we have all of our power plants come on and offline all the time. Whether it's coal plants or gas plants or whatever, you know, they're running up and down to meet load, but they're also coming offline to be repaired. Nothing runs 24/7, 365 days a year, and so we need to have a system that can handle that. So with that as kind of the backdrop, that's an important thing to remember, that we have these redundancies built into the system. And so you start pushing renewables into the system, they're kind of doing what the system was already designed to do and was already able to handle, and that's up and down and back and forth in the system. And just the natural fluctuations that you see in demand. And so the system is you know, has that built-in response to it. I think where we're fundamentally starting to see things differently now is that was all well and good when renewables were at the margin and you kind of had 5 or 10% of renewables pushing into the system. I think where the game has suddenly changed on us is that renewables are now incredibly low cost, and they're coming into the system. And then they also, as we're seeing in the last 4 months under the COVID world, with zero marginal cost, they also become the first that bid into the system all the time. And so when everyone else backs down, you know, you're still pushing those renewables into the system. And so the system is reacting a little bit differently. And we're starting, you know, we have to sort of think about putting all those things together. Low cost renewables, more abundant. How do we then handle all of that? And that's going to be a different answer for every different system.
And I remember years ago, people were debating, you know, what percentage of renewables a power grid could handle, 4%, 5%, you know, you just talked about 5 or 10%, and I assume it's a lot more now. So what percentage, I know that fluctuates, so there isn't a number, but generally, you know, how much can the Alberta grid handle in terms of wind and solar?
Right, so this was an interesting question. So I worked for the government for a couple of years prior to joining the U of A, and that was one of the questions that was looked at, because obviously at the time there was a policy around coal phase out and renewable growth, and so the big question was, how much can the system actually handle? And you know, that comes down to all those things I was just talking about a moment ago in terms of what backups do we have in the system, other questions around transmission capability and all those other questions. And it turns out no one had really actually sort of done that modeling. And so it was put out to a couple of companies, including the Alberta Electric System Operator, who basically said, you know, it turns out we can handle 30% renewables, even if it all comes in as wind, with basically the current system, and without a whole lot of fundamental changes to business as usual. We could add about up to about 30% renewables, and at the time we have a handful of percentage of biomass and hydro, so it'll be fundamentally about 25% wind to get to that number. Subsequent to that, so that was 2015, 2016 timeframe. Subsequent to that, there's been, I know, other private companies that have looked at it and probably said we could push that number probably closer to 40 or 50%, without sort of major fundamental changes to the system. Getting beyond that, you're starting to think about, okay, how do we start to redesign system? How do we integrate batteries and connections and all these other things? But it was sort of surprising to me, those numbers, without sort of major changes to the system.
I want you to respond to comments
now,
that made to me.
I don't want to run on too much, but let me just qualify. Okay, go ahead. Sorry.
Well, a couple of years ago, I interviewed John Riddett from NMAX, who's their VP of Planning, and he used the analogy. He compared the Alberta power grid to the telecom systems in the 1990s. So they used to be fairly simple, and you had a landline, and then you got cell phones, but really they weren't very complex. And then in the 90s, they got completely re-engineered, and there was new infrastructure built, like fiber and so on. And he said now it's like a structure that you can hang different types of telecommunications off of. So you got internet and cell and landline and voice over IP and all of these things, and the system integrates them smoothly and makes them work. And he said that's where we're going with electricity, as we redesign the modern power grid, so that we can have all of these, we're going to have biomass and wind and solar and gas and residential generation, et cetera, and it all works smoothly at a reasonable cost, and it's reliable. And so that was his explanation. What do you think of that?
Yeah, I mean, there's definitely some truth to that. I think, I think it's not a perfect analogy, but because there's certain differences between the two systems, but there's definitely sort of a fundamental rethink of the overall system that's going on right now. I think one of the more interesting things, and maybe it's starting to settle a little bit right now, but I think one of the more interesting things is that the future is a lot less clear now than it was 10 or 15 years ago. And I think, and I'm not a telecom expert by any stretch, but I imagine that they probably saw some of these other changes coming a little bit better. I think that the renewables game, the electricity system has changed a little bit faster than I think people thought, and the infrastructure costs are longer, right? And so when you're building a coal plant or a gas plant or a transmission line, you're expecting sort of a 40 or 50 year turnaround on that in terms of sunk costs, right? And so when I think things have crept up, and renewables, the cost came down faster than I think people anticipated and were able to kind of react to. And so I think we're playing a little bit more catch up to figure all that out. And so there's definitely change going on, and definitely the system is being re-engineered to cope with that. But I think it's a little bit, there's some big question marks out there that I think people are still wrestling with at this stage of the game. One being storage. So do I redesign the system assuming that storage will be 20 years out, or do I redesign a system thinking that storage will be 2 years out? And you come up with pretty different answers depending on which of those two things you assume.
Tim, I know you keep a close eye on Lazard's levelized cost of energy studies, and I do as well, not as an informed view, but nevertheless, the last ones that came out in late 2019 showed that at the bottom end of the estimate, wind was $28 a megawatt hour, and solar was $32 a megawatt hour, and these would be in American prices, and which was quite a bit cheaper than gas at 44 and new coal at 66, I think it was. Are those numbers roughly equivalent for Canada? Is that the cost of electricity that roughly that we can expect here?
Yes and no. So I think this is one of the complexities of the system is that, well, there isn't a system that we have in Canada. We have, 7 or 8 different systems, which are relatively poorly interconnected to each other for the most part. And then with renewables, you have fairly, wind in particular has a pretty finicky dependence on its resource. So a strong wind regime is much better than a very strong wind regime is much better than a good wind regime, shall we say. So even small differences make huge differences in overall output. And then solar becomes a little bit more complicated because as you move further north, not only does the resource weaken a little bit, but the seasonality becomes a huge difference, right? So our winter versus our summer, as we know in northern Alberta, there's just a huge difference. So that doesn't change necessarily the levelized cost, but it does sort of change how you would think about it in the overall system. You're going to have a pretty big different fluctuation from the summer to the winter. So that's, and then the last point, and so I'm giving you a complex answer because it's a complex question, is that gas prices are going to change depending on where you are in the country as well. And so Alberta's got pretty low gas prices. It can be a little more expensive in other parts of the country. So those prices will change a little bit. But broadly speaking, yes, to answer your question, you will see costs sort of in that range. Those are type costs that we expect to see. Wind being probably the lowest cost, new build technology. I would say gas is probably number 2 in Canada, and then solar is probably surprisingly close to number 3 right now.
So you made a comment that caught my attention a few minutes ago when you talked about the marginal cost of renewables being almost 0 in Alberta. Could you explain that, please?
Right. So this is where this is kind of what we're interested in, and what we're actually studying specifically is the fact that wind and solar have no fuel cost. And so what that means is that they enter the market whenever it's windy or sunny. There's no reason at all, when there's no storage in the system, there's no reason at all not to throw all of your power onto the market. Whereas any other facility has an incentive to hold back. Because you've got a fuel cost and you have, maintenance costs, and or in the case of hydro, you've got a limited amount of water that you're going to want to dispatch when it's most valuable to you. So the thing with wind and solar is there's no incentive whatsoever to not throw everything you have into the system. And so what we call the marginal cost is 0. You've got no fuel cost you need to add. And so anytime it's windy, it's sunny, it goes into the market. And the way our market works in Alberta, and it's fundamentally the same everywhere, is that so we bid into the market at 0 into the market, and then that depresses the whole market price down, and then it pushes someone else with a marginal cost out of the system. So if you have enough of that, then you end up with a scenario where we've actually seen in the last week, for those who have been keenly following the Alberta electricity market price, which I'm sure you all have, we've actually seen $0 hours when it's been windy and low demand. So we actually see the whole market settle at 0. So this becomes sort of the interesting question then: what happens in that world? How do you then how do you deal with that? And that's all well and fine when you can push the top end guys out of the stack that are flexible. But what happens then when you run into a situation where suddenly you've got non-flexible people you need to push out of the stack? Or theoretically, what happens when the whole system is running on wind? As an argument's sake, who do you kick out of the system in that scenario? So that's where life kind of gets interesting. And Texas, which has a huge amount of wind, as you know, and solar, so they've got negative pricing in their market now. And so then you do encourage someone to, so even if you have a 0 cost marginal bid, if the market goes negative, someone has the incentive to pull out. We don't have that in Alberta. We have 0 cost right now. So even then there's no incentive at all for a renewable generator to pull out of the market. In fact, they would stay in because they for the most part, would have an offset or an environmental attribute that they continue to monetize. So they would still have some value even if the market's settling at zero. So I know it was a simple question, and I gave you a long-winded answer, but that's kind of the fundamental question that sort of we're interested in. But broadly speaking, how the market integrates renewables. So there's an electrical question, how the electricity system integrates renewables. How the market does it is kind of is another question, and they're obviously linked to each other, but it's not a trivial answer.
Well, the good news is it was an interesting long-winded answer. A few years ago, I interviewed CSP Energy, which is San Antonio's publicly owned power utility. And I asked the question of the Rudy Garza, the fellow I was interviewing. I said, what do your engineers think about wind and solar? Because, these are coal guys, right? And they go, oh, no, we love it. They love it because no fuel, no variable costs. All you have is your fixed costs, and then a very small amount of maintenance cost and whatever cost capital. And other than that, no fuel costs, which engineers love. And so what's the take in Alberta and maybe outside of Alberta from utilities? Because I remember working with SAS Power in the 1990s, and man, they are that old monopoly, approach to energy, and they don't move unless they're really, the big shock, or they get directions from above. What's your take on that?
So unfortunately, I'll probably give you a bit of a long-winded answer again. so buckle up. But first off, I do want to say things have changed a lot in SAS Power in the last little bit, just to be fair to them. But your point is well taken historically. So the challenge comes down to how the market is set up. And this is where my life kind of comes in, where it's this interconnection between engineering and business. So if I set up a market where I own top to bottom the electricity system, right? So if I'm a utility that's a crown utility in Canada, or a state utility in the States, I will think about renewables in a different way versus if we have a competitive market in the system, right? And so if I am a crown utility, the advantage of renewables is, as you said, they've got zero cost, marginal cost. And so every time I'm dispatching them, I'm saving fuel somewhere else. And I think one of the interesting things that is kind of new on the block is that wind can be surprisingly dispatchable and really, really quick to dispatch. Obviously, it's easier to dispatch down than it is to dispatch up, but you can response time is really, really quick on wind, whereas there are other bigger machines have larger inertia, and obviously some of them can ramp up and down really, really quickly, but not all of them can, and to varying degrees. And so wind actually has a very quick response time, one of the best, and so we don't have to think about it in that way as a resource that way, but it is starting to be thought about more and more, and it was being considered how you can dispatch it up. Even. And so the way you would do that is I would run all my wind fleet down at 90. You can pitch the blades back, and I would run them at like 80% or 90% output. And then you can actually call on them to dispatch up if you want to. That obviously, works when it's windy and X, Y, and Z. You have to overbuild and all these other types of things. But it's an interesting question that we never really sort of thought about. You would have, 15 years ago, if you can imagine sort of someone saying, well, I'm going to use wind to dispatch up or wind to back up wind. No one could imagine that scenario, right? So if you're sort of a broader owner of the system, you might think about renewables in that way. However, on the flip side of the question, it then comes down to, okay, do I own the renewables or does someone else own them? And when they push into the system, they're pushing the market price down for everybody, including themselves. And so they may not be everyone's favorite in that regard. Good for the consumer, but maybe not so good for the broader market. So that's where it kind of depends on how the market structure is set up and how who's dispatching what. But yeah, so that is a bit of an insight too.
Interesting. This will be the last question that I have for you, and then we'll open up the mics for questions. So remember to get your question together and figure out where that little blue hand is. So here's the question. You mentioned that the various systems in Canada are not well integrated. Would it be better, and I know I should also say that there's been a lot of discussion over the years about at least integrating the Western Canadian grid, but would we be much better off if we integrated at the Western Canadian level and then B, at the national level?
Right. So this is the multi-billion-dollar question, and a very good one. I think so. I'm struggling to give you short answers here. I think where Europe and the United States, in some cases, have done very, very well at integrating renewables has been because they have a much, much better integrated system than we do. One of the reasons we don't have a great integrated system is because we're a huge country with very few people in it. And so a power line is still going to cost me a lot of money per kilometer to get to British Columbia. And there's only 5 million of you over there, and there's only 4.5 million of us over here. And so I can spend a lot of money on a huge transmission line for not a whole lot of power that's going to move back and forth. So from an engineering point of view, I would love to see that transmission line. I would love to see one there. I'd love to see one to Saskatchewan. Saskatchewan connected to Manitoba and probably connected to the Northwest Territories. That'd be fantastic. The question is, how do you make those economics work? And that becomes a pretty tricky question, especially so this comes back to the very first thing I was saying a moment ago. It comes down to, that's a very different answer if I think storage is 30 or 40 years out or never comes. If I think storage is going to be economic in the market 5 years from now, and I invest $20 billion in a transmission line to British Columbia, it's a whole different world. So I think that's where life is a little bit complicated right now. And I don't think anyone's got a great answer for that. I think if I were to just to get rid of the cost, and from an engineering point of view, I would love to see the system interconnected. Western Canada, I think I would stop at Ontario and let Ontario and East connect, and then Manitoba West connect. Getting through Northern Ontario is just so big with so few people that it doesn't fundamentally make a whole lot of sense. So if I was thinking about it from an overall system, that's what I would do. I don't think anyone has a great answer for that right now. People are thinking about it. People have been proposing those transmission lines. The world, and you've got this great interplay of big hydro resources on both ends of that spectrum and huge wind and solar resources in the middle. And so there's a natural tendency for Western Canada to play well with each other. Low-cost storage throws that whole question. No one knows what the answer is to that question. So that's a very long-winded non-answer for you.
Dave, if you could unmute your mic and ask your question of Tim, please.
There's a couple of pump storage projects on the works in Alberta. They're expanding the Brazeau Dam by, I think, 900 megawatts, and there's 75 megawatt project in Jasper. I'm wondering how those are coming along and how they're going to help the grid integration in the future.
Yeah, great question. So there's talk of both of those projects. Whether they come or not, I think is another question. So the advantage of storage, as you mentioned, or as we've sort of talked about before, is that it can take advantage of, so we get to these zero bidding hours, and now I can start charging my system. It then will push the market price back up, so it's good for renewables, and then you can arbitrage and sell that power somewhere else, a different time of the day. And so, yeah, big advantage to those systems technically, again. If one of those two projects were to go ahead, my suspicion will be, and this is just me personally speaking, would probably be, we'll see the smaller projects go first. Alberta's market is small enough that a 900 megawatt introduction into the system fundamentally changes the whole market price. We've seen that with the Shepherd power plant south of Calgary. You introduce that much capacity into the system, and suddenly the whole market has to readjust to that. So my guess is that project is a bit too big to go right now. From an economic point of view, from an engineering point of view, it'd be fantastic to see it there. I think it'll be a bit of a challenge for that project to get off the ground, at least until we have a little more clarity sort of how the rest of the system is going to shake out. So I'm not saying it's a bad project. I would love to see it. I think the economics of it, especially of that size, will be hard to pull off without a little more clarity about how the broader market looks. If we end up in the world, so the other, on top of all the complexities we've talked about today, who knows what happens with COVID, right? And what bounce back do we see 5 years from now, 2 years from now? If we start to see oil projects drop off and our demand drops, we're going to be an oversupply world in Alberta for conceivably for quite some time. And then that it really hurts the market case for storage, because storage kind of needs that change in market from low price to high price to make it work. And so without that difference in value, storage will be challenged in Alberta in the next little bit. So again, long-winded answer to your question. The short answer again is from an engineering point of view, they would be super helpful. We have the transmission capacity to kind of the Brazeau area and the coal area as well. It would be great for the system. The economics are uncertain, shall we say, at this stage.
Good stuff. I'm going to call on Joe Vipond. Unmute your mic and ask your question, please.
Can't hear you, Joe.
Sorry, Joe, we haven't, your audio is not working. While you're working on that, I'm going to ask Brian Heidecker if you would unmute your mic and ask your question, please.
Well, I think hopefully I have a simple question. So, Tim, what is the average wind turbine? What percentage of the time are they generating power over the course of a month, a year, or whatever?
Okay, so I will take your simple question and give you a complex answer. So things have changed a lot. So the technology has changed in the last little bit. So if you're asking how often is it generating power, most turbines would actually be generating something sort of on the order of 90%, 80, 90% of the time. So they're often they're very rarely sort of generating zero. They might be generating 5% of their output, or they might be generating 95% of their output, but usually it's somewhere in that range. And so we've actually seen, I think we're at a stage now with enough wind in the system that it's very rare that we actually see zero wind output any time of the year in Alberta. Now that said, there's ups and downs and fluctuations, and so if your question is how often is it generating power, it's most of the time. It's sort of in the 80% of the range for most of the modern turbines. If you want to sort of the average output, it's modern fleet now, we're sort of expecting to see 40, 45% of what we call the capacity factor. So that would be, if you've got a 100 megawatt wind farm over the course of the year, you would expect to see a 45 megawatt on average output, but obviously that's going to change up and down. So again, long-winded answer to a simple question, but renewables are pretty complex that way. So.
Tim, I've got a related question. That is, you mentioned earlier that the cost of renewables fell more quickly than people anticipated. And where are they going now? I mean, if they're already the cheapest form of power generation, are we expecting to see a significant drop over the next 2 years, 5 years, 10 years?
I don't know. So I remember I've been in wind. 1999 was when I started looking at wind energy, my master's degree. And it was shortly after that the 1 megawatt wind platform was introduced. And so if you look at Alberta's fleet, it's got these 0.66 Vestas 660 kilowatt machines, so less than a megawatt. They were kind of the workhorse of the industry for a bunch of years. And then this 1 megawatt platform came out. And I remember people thinking, wow, 1 megawatt, this might be as big as we ever get. And some of the reasons for that was just the logistics of moving the huge blades around. You're starting to get into steel bolt strength, when you're bolting the blades onto the hub and all those types of questions. And now it was just last week, the 14 megawatt offshore platform was announced from Siemens. Which is crazy. And we're installing the turbines we're seeing in Alberta are coming in sort of in the 4 megawatt range now as kind of that's run of the mill, standard input or development these days. So the answer to your question is I don't know. It's like computers, right? We sort of thought, well, this is as good as they're going to plateau at some point in time, and they just haven't. Now, wind, I think, is more likely to see a plateauing at some point in time because you run into those mechanical, mechanical issues at some point in time. But it seems like just the economies of scale have continued to drive the cost down. And I don't see wind. Wind is starting to plateau. It beat solar down to sort of grid parity and below, and it's starting to see a bit of a plateau, but it's still pushing downwards. And solar just doesn't seem to stop. And so I don't know where it's gonna end. It's got to stop at some point in time, but it doesn't look like it's plateauing a little bit now. So the big jumps we saw in the last 2 or 3 years have happened quickly. But a huge chunk of the reason that solar has come down in price has been the manufacturing and the huge economies of scale that have happened there. The technology is not that much different than it was 20 years ago. There's definitely improvements of efficiency, but it's really been the manufacturing scale that's come down that's pushed everything way down. So my guess is we'll still see there's still costs to come down yet, and I think this is suddenly why in the last 3 or 4 years to your point earlier about the Lazard study, right? When we suddenly saw wind and solar pushing down below everything else, I think everyone kind of woke up and said, this is a genie that's out of the bottle and you don't put it back in, right? So you're never going to see wind and solar push up above these other costs. It's just impossible. That anything that has a fuel cost is suddenly going to be a disadvantage. So how do you react to that? And so that's where you're starting to see this big shift in the US, just that fundamental thinking, instead of sort of saying, well, it's nice to have these things at the margins, to how do we integrate a lot of this stuff now because those costs are just, are so low. So that's, I'll shut up.
Pam, if you could unmute your mic and ask your question of Tim, please.
Hello, thank you for having me. Tim, I have to say I did a degree in mechanical engineering at U of A as well, and I looked you up, but you're a lot younger than I am, so I was long gone before you were there. My question is, I'm curious about this really low cost and this concept of negative pricing for electricity, which I don't know, makes me happy on some levels, but at the same time, I see obviously prices for storage increasing. So it's sort of a two-part question. One is like, how do you see the costs of storage sort of being introduced into the costs of what we pay for electricity? Like we currently pay for transmission and production. Are we going to have a cost as well on top of that? And the second thing is, I know we have a few small hydro storage projects hopefully coming on, but what do you see as a potential, like where Alberta will go as far as storage? Because I know there are a few hydro, but probably not that many. Thank you.
Right. Great questions. And it's murky still how it's all going to unfold. So the way we would think about it now is we would imagine storage sort of behaving like any other system, any other player in the market. And so they're just going to draw power to charge up, and that will then sort of push the market price up a little bit, and then they push it back into the system another time, sort of pushing the market price down. Now, as you know, there's no free lunch. The second law of thermodynamics will mean that we lose some energy in that process. And so net, that has a slight increase in power costs. But if it does mean that I can push more zero cost renewables into the system, then maybe it's not a huge overall change to the market. The big question becomes, if I imagine a system, so let's say in Alberta, where we're relying on being able to buy very, very low cost power on one end and then selling it at high cost at another time of the day. If I imagine I've got a bunch of storage in the system, I'll eventually sort of flatten that. I'll eat my own lunch, if that makes sense, right? So if I'm buying low cost and I put a bunch of storage in the system, I actually start pushing that cost back up because I'm putting more load on the system. And then when I'm bidding back into the system, I'm then going to push the market price down. And so storage has this funny problem where it eats its own lunch, and it's a bit of a challenge knowing, so I'm going to build my storage system. What happens if another guy comes along and builds another storage system? So how do you sort of make that bet? So I don't have a good answer for you because I don't think there is one just yet. We haven't totally figured that business model out right now. And you get a very different answer, going back to my earlier point, in a private market like Alberta's versus if I'm a fully integrated utility I'm going to think about storage in a very different way. I'm pretty happy to see a flat market price if I'm an integrated utility. If I'm someone that, if my storage system relies on that arbitrage, different question, right? So that's where I think we haven't quite got the business model for it figured out just yet. But I don't think you would expect to see it show up as a transmission rider or anything like that. Right now, the way it's set up in the Alberta market is it would enter the system as a load and as a generator.
Tim, I've got a related question for you. Last year, I interviewed a fellow named Bertha de Bray, and he is responsible for integrating EVs into the Netherlands power grid. And he thinks that this is technically doable. They have some issues around resourcing people to do the designing and engineering. But he said that China, Netherlands, and the US are kind of leading the charge on this. But he expects it to be done over the next, I forget, a couple, 3 years, maybe 5 years, forget just exactly. But what's your take on electric vehicles in garages being available to act as battery storage for the power grid?
Give me one sec. Pardon me. So I'm, as an electric vehicle owner myself, I'm a little less optimistic about that prospect. And to me, the question is going to be, I guess, the size of the batteries that these vehicles have on them. And if we get into the world where 500 and 600, 700 kilometer ranges on vehicles are standard issue, then maybe it's a different story. We're not quite there yet. And I think people's willingness to be able to sacrifice 10 or 15% of their battery in any given moment, right? Because the only way this works is if I have that ability to push and pull. It means I have to be willing to give up 20% of my range in any given hour. I mean, you can override that on X and Y and Z, but the point is, I'm not sure that people are that open to that idea for a pretty marginal gain, right? Like, it might save me a few bucks a year. It definitely adds up. If the whole system operates this way, it's a super huge technical advantage. I'm not sure the consumers are super excited about willing to give up, sort of altruistically, a tenth of their range for $20 a month, right? So I think technically, there's possibility for it there. I'm not sure that we're quite there yet from a consumer willingness to buy into it, unless you're told you have to, which is a different story, or unless you're really not sort of giving up any performance. And right now, I think cars are probably not at the range where you'd be willing to give up an acceptable amount of performance for that. I think where there might be a shorter term opportunity is what we're seeing in Prince Edward Island with electric hot water heaters. And that's a much more dispatchable system, which doesn't really have sort of the consumer sacrifice. You don't recognize that consumer sacrifice on the front end. And so what they've got in Summerside, Prince Edward Island, they've got a bunch of wind, and they've switched a bunch of their consumers onto electric hot water systems. And then they can, when it's really, really windy, they can charge those electric hot water heaters. And then when it's not windy, they can wait a couple hours to do it a little bit later. So there are other options there. I'm not, at least in the Canadian context and the current EV technology, I'm not quite as convinced we'll see the push and pull from electric vehicles, at least in, I would say it's probably at least 10 years out. And I think you probably have to make it a lot more lucrative for consumers to make it make sense. Our electricity bills just, aren't that much to be able to push and pull a few kilowatts for that sacrifice and convenience.
Joe Vipond, if you could unmute your mic and ask your question of Tim, please.
Oh, Tim, I'm going to challenge you to answer a question without saying it depends.
Sorry.
I have more of a comment than a question. Actually, no, that's just the standard thing. What I really want to talk about is thorium, and actually, no, that's not true. What I really want to talk about, which is super complicated, is the balancing pool. Yesterday, yeah, I know. Yesterday, during the Zoffee, I noticed the zero electricity price, and I reached out to Blake Schaefer, who noted that 76% of the coal that was online at that time was balancing pool managed assets. And my understanding is the balancing pool is supposed to run their assets in a commercial fashion. And it would seem to make sense to me that if the supply exceeds the demand, the first things that should go offline would be balancing pool coal. Because balancing pool is operating this on behalf of the taxpayers. The taxpayers are also healthcare, users in Alberta who are, suffering from the air pollution effects of coal and the GHG effects of coal. And it would look much better to the world if we had decreased coal online. Anyways, can you comment on why the balancing pool isn't acting the way it's mandated to act?
And before you do that, Tim, I want to ask you if you could briefly tell, because not all of us know what the balancing pool is, if you could give us a brief explanation of how that works.
No. I'm gonna try to skirt this question a little bit, Joe, because I think it's a complex one, which is going to sunset relatively soon once the balancing pool contracts end, right? So to back up really, really quickly for everybody, I'm trying to debate how the fastest way to answer this question is. But when Alberta deregulated, oh man, how do I do this quickly? I don't think I can do this quickly. when Alberta deregulated its market, so Markham, I'm gonna avoid answering this question because or not answering this particular question. I'm gonna avoid getting into the balancing pool history because I don't think I can do it quickly, frankly. Maybe someone else can do it better than I can quickly. I'm worried that I'm going to spend 15 minutes trying to explain it all. But we have these contracts which are owned by a government entity, which basically dispatches a certain amount of largely coal into the system. And historically, those contracts were owned by other private companies, and they used a clause to, when environmental rules changed, to then transfer them back to the government. So the government is temporarily holding, or a government agency, I should say, the balancing pool is temporarily holding these contracts, which it bids into the market. And so they're pushing the power price down right now by bidding in some arguably non-commercial manner. If I'm going to sort of play devil's advocate on behalf of the balancing pool, Joe, I think that their argument might be that they would rather get something for the price rather than nothing, or something for their contracts rather than nothing, and so they're trying to capture something from the market rather than pulling out entirely. But I think that is an open question as to whether they are in fact behaving in a competitive way. And if, by and large, they are bidding at low cost and sort of suppressing the whole market price overall for everybody, which I don't think you would see if the contracts were in private hands. All that said, and so I'm not giving you a great answer here, it is sort of a temporary question, right? The balancing pool contracts don't last that much longer. And from a broader system question and a broader renewable energy integration question, it's a short-term problem.
Fair enough. We're going to allow one more question. So Dave Patterson, if you could unmute your mic and ask it of Tim, and we'll try to be out of here in about 5 minutes, Joe.
Okay, I was going to mention Fort Chip put in, I don't know, 3/4 of a megawatt of solar to offset diesel fuel. And they also added some battery storage just to, buffer their grid. It's an isolated grid. They're not connected to the outside world. But it also allows them to shift their excess solar during the day into the evening. So does that apply to other places that are more grid connected?
Yeah, super interesting question. So I got into renewables in the off-grid. That's kind of actually where my PhD area was off-grid renewables. And what was kind of interesting was the questions that we were wrestling with 30 years ago on the small scale are the questions that we're looking at on the big scale right now. So when I started pushing 20, 30, 40% in some cases. There's an Antarctic wind turbine, 3 wind turbines that runs at a 90% wind for the overall system. So those questions were sort of being looked at in the small scale before we were looking at them in the large scale. I don't, on that particular question, I don't actually know if they've got the battery system there. In fact, I'm pretty sure they don't have it there yet. I know it's been talked about, but yeah, they have put this big solar system in to push diesel prices down demand down by, I think, about 25% of the overall over the course of the year. But it is kind of an interesting microcosm, as you said, to what sort of the broader system will be looking at. And so I think we definitely will see that model applied at the larger scale with storage coming into the system. We're seeing it happen commercially on its own. There's been competitive bids in Illinois and California where storage is just showing up on its own, unsubsidized, and being able to compete. You're seeing hybrid systems being built with storage right on site, so you can have a dispatchable renewable facility right on site. So that's happening in the market on its own. And so you're right. I think that's kind of you see there's remote communities that are pushing at the leading edge of some of these, what we're going to see in the broader system. Just to repeat the point I've made 3 or 4 times, the big question, well, there's obviously big electrical engineering questions, but I think the big question that I think we don't have solved is how the market handles all of this. And so I think, and it will depend on which market you're in. And so I think that's an interesting area that we're still sort of seeing unfold, is how we integrate all this from a technology point of view, but also from a market point of view, and how we make it work. And that's going to depend on the local jurisdiction you're in and the local market setup.
Tim, thank you very much for this. We really appreciate it. I've learned a lot, and I'm sure everybody else has as well. And despite your claim that you were long-winded, you actually weren't that bad at all. These really are complex issues. And I think it's important that those of us who are interested in energy at least have, working knowledge of this stuff and what some of the issues are. So thank you very much for this. And we'll look forward to getting you back in another 6 or 12 months and see, because it seems like change is rapid, and I bet you a year from now we might see, who knows what the prices will be, who knows what the technology will be, and so on. So thank you very much for this.
Well, thanks so much for having me. Great questions. I really appreciate the dialogue. So thanks everyone for your interest in being engaged, and yeah, complex territory. So there'll be no shortage of things to talk about a year from now.